lesson, chapter 11, lesson 7, which we're going to get to in a moment, is going to deal with more volume. But then our textbook has, right before this lesson, a 2-page extension lesson on density. But of course, it's a whole standard on the EOC. So I'm going to talk about density today and then you get into lesson 11.7. So here we're going to use density to solve problems. And depending upon what science class you're in this year, you might have worked with density already. It is an 8th grade science standard. I know a lot of my students though are in biology. So density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. And you know about density. I'm sure you've learned about it in science classes, but basically it's that idea that sometimes you go to pick something up and it feels lighter or heavier than you think it should because of its density. Different materials have different densities, so density can be used to distinguish between materials that look similar. For example, table salt and sugar look alike. However, table salt has a density of 2.16 grams per cubic centimeter, while sugar has a density of 1.58 grams per cubic centimeter. So if you fill up a large volume of the two, the sugar will actually weigh less or feel like it weighs less than the salt. So determine which substance has a greater density. This is also used later in science to figure out which objects will be better for a certain activity. So for instance, a piece of copper with a volume of 8.25 cubic centimeters has a mass of 73.92 grams. Then we have a piece of iron with a volume of 5 cubic centimeters, has a mass of 39.35 grams. Which metal has the greater density? So as you see, you can't compare them here by picking them up or feeling because their mass and their volume is both different. But when we take the mass of the copper and divide it by the volume, we get 8.96 grams per centimeter cubed, and for iron, 7.87 grams per centimeter cubed. And density is going to be constant for the item it is. So if we said we had this much mass and this much volume, find the density, and then tell us if we had 90 grams of copper, what volume would it be? We can do these proportionally. But in this case, we can see that copper has the greater density. So not to be outdone, social studies would also have its use of population density. Another use of the word density occurs in terms of population density. And the population density of a city, county, or state is the measure of how many people live within a given area. So you might have dealt with population density last year in civics. It did used to be a topic that came up a lot when 7th graders had world geography, but that class no longer exists. So this may be the first time you're hearing of population density, but it's usually given in terms of square miles. It can be expressed using other units such as city blocks. So you can talk about how many people live on one city block compared to how many people live on another city block, or how many people live in a certain subdivision compared to others. So the population of Vermont in 2009 was 621,760. Now, rather than telling us how big Vermont is, they say that it can be modeled by a trapezoid with these vertices, with each unit on the coordinate plane being 1 mile. So basically, when you graph out 0, 0, 0, 160, 80, 160, and 40, 0, you get a trapezoid. These are the two bases, the parallel bases, 40 miles and 80 miles. And we're going to use the trapezoid formula, base 1 plus base 2 times height divided by 2, to get that the area of the state of Vermont is about 9,600 miles squared. So if we take the number of people and divide it by the number of miles squared, we get 64.8 people per mile. So in 2009, there were almost 65 people per square mile living in Vermont. Now, they could have given us Vermont, told us it was a trapezoid, and done the same thing with, say, New Mexico, and told us it was a rectangle, and they could have even asked us what one is higher population density by how much, etc. You're going to get a chance at the end of this unit for homework tonight to do a few density problems. So now we're going to move into our lesson to find the volume of pyramids and cones. And we're going to use a lot of what we've already learned about finding volume of prisms and cylinders in order to find the volume of pyramids and cones. So first off, we have some warm-up exercises. To find the area of each polygon or circle, we are going to hold off, as I said earlier, on regular hexagons and things that are not square, four-sided, or circles. We're going to do that later in this chapter. We're doing this chapter a little bit out of order, so we have not yet learned how to find the area of shapes greater than quadrilaterals. A circle, though, we do know how to find the area of a circle, and that is, if my slate wants to work here, let's see. The radius is 15. I'm going to wait for the slate to turn on. So 15 squared, so 15 times 15 is 225 times pi, and I'm going to use times 3.14 to get approximately 706.5. Remember, we're going to round a little bit differently because we're using 3.14 and this book is using a pi bun. Now find the area of each polygon or circle. We have a right triangle with a hypotenuse is 12 and a side length is 6, meaning we have to find, this is a base and a height, we need to find this other number here. So 36, because 6 squared is 36, plus b squared is going to equal 144. 144 minus 36 is 108 square root. So approximately 10.392305. I'm going to multiply that times the other dimension, which I'm going to call the height, and get 62.353829 divided by 2 is going to give me an area of roughly 31.18 if I round to the nearest hundredth. Then for this, solve this problem, 2 to the third power squared. So 3 squared is 3, 2 squared is 4, so that becomes 12 square root of 3 over 12. So those are going to cancel out. I'm going to have the square root of 3 times x, so x square root of 3 equals 15 square root of 3. So I can see there that x is going to be equal to 15. I know I'm going through these very quickly. We have a lot to do, and for some of you who know how to do all this, I don't want to bore you. So if you need to, pause the video and rewatch what I've just done. So now we're going to get into formulas for pyramids and cones. And basically the short version of this is when you have a shape that ends in a pointy top, it's not a prism, it's either a pyramid or a cone. And basically you're going to use a formula like we used before, but we're going to multiply by a third. So recall the volume of a prism is the area of the base times the height, where b is the area of the base and h is the height. In the figure at the right, you can see that the volume of a pyramid must be less than the volume of a prism with the same base area and height. As suggested by, we didn't do the activity, but the volume of a pyramid is 1/3 the volume of the corresponding prism. So for a pyramid, we find the area of the base, multiply by the height, and divide by 3. Same thing for a cone. Find the area of the circular base, multiply by the height, divide by 3. I always tell students, even in my pre-algebra classes where we do this a lot, don't try to multiply by 0.3333. You'll get rounding errors. Better to divide by 3 at the end. And so we can actually apply this. This is a pyramid. It has a triangular base. It has a pointy top, so it's not a prism. To find the area of the base, 4 times 6 is 24. They're going to then do the half then. I usually just do 24. Half of 24 actually is 12 for the, I see they're finding the area of the triangle. So 12 times 9 is 108, divided by 3 is 36. And we can do the same thing here. You'll remember yesterday when we learned about Cavalari's principle, since we can use the same formula for the volume of a cone, even though it's oblique, it's tipped over to the side. So the area of the base, 2.2 times 2.2 is 4.84 times 3.14, so times pi. I know they're doing pi at the end. I usually do it before I divide by the third. So 15.1976 times 4.5 is that number divided by 322.8. So we round to the 10th. If we round to the 10th on either of these, we would not have to deal with that rounding issue of pi, but that's why the answers in the book vary a little bit, and maybe next year I'll go through and actually retype all of this. So now we can use algebra to work backwards to find the square length, the length of a square base. We have a pyramid that had a height of 144 meters and a volume of 2,226,450. So we're going to plug into our formula what we know, and the base, I think there's a mistake here personally in this. This should be the area of the base, not the small base. So I might have some issues here. So I'm going to go ahead and redo this. 2,226,450 is going to equal 1/3, oh, they did this part right, of the base squared times 144. So they did do that right. I was a little concerned since I saw that lowercase b. So 144 divided by 3 is 48. And I'm going to take this 2,226,450 and I'm going to divide it by 48. And I'm going to get 4,638.4.375. And when I take the square root of that, I get that the side length of each square base is about 215.4. And you would still get approximately 215 rounded to the nearest whole number. Yes, it would be helpful if the book told you when they wanted you to round and to what space. Let's see if they did. No, they did not. So it would be more helpful if they said that. We never really know what they're going to ask us to round to. This guided practice, we're obviously not going to do this one because we have not learned how to find the area of a hexagon. We will learn that, and we will come back and do those problems next week. So I did this problem twice and couldn't get the right answer, and then realized what I'm doing wrong. 8 meters here is not the height. It's the hypotenuse of this right triangle. In order to solve this problem, I need to find this measure, the height. So 5 squared is 25 plus b squared equals 64. And 64 minus 25 is 39. So if b squared equals 39, the height of this is basically 6.25 for the height. So now to find the area of the base, 5 squared is 25 times 3.14 is 78.5 times 6.25 is 490.625 divided by 3 is 163.54. If we round it to the nearest tenth, it would be 0.5, and here would be 0.5. Once again, has to do with the fact that they're using a pi button and we are using 3.14. Now we're going to find the volume of a right cone is 1,350 pi. So since we have pi, we're going to set up the formula. And nice thing is, because we're going to cancel out the pi's, we're not going to have rounding issues. So the pi's are going to cancel out. 1,350 is going to equal 1/3. The radius is 18. So 18 times 18 is 324 times the height. 1/3 of 324 is 108. So 1,350 equals 108 at h. 1,350 divided by 108, h equals 12.5. So the height of this cone is 12.5. Now comes the point of the lesson where Mrs. Falk's evil laugh. Ha 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 ha. Because we are going to use trigonometry to help us find the volume of the cone. So, in this problem, we have a height, and they've told us that this angle here in this triangle is 65 degrees. But we do not know the radius. We want to find the side adjacent to the 65-degree angle, and we also have the side opposite. We do not have a length of the hypotenuse. So therefore, we're dealing with a tangent. So a tangent of 65 is equal to opposite over adjacent. We can rewrite this as 16 is equal to 16 divided by the tangent of 65 is approximately 7.46. In our calculators, I know I don't have the right calculator there, but if I do 65 tangent in my off-screen scientific calculator, it's 2.1445. And then you can see here that 16 divided by 2.1445 equals about 7.46. So now that I know that that radius is 7.46, I can plug it in. The radius squared, 7.46 times 7.46 times 3.14 for pi times the height, which is 16, is that number divided by 3 is approximately 932 rounded to the 100th. Once again, rounding issue because this book is using a pi button. And now we're going to find the volume of a composite solid. So we can see that this is made up of a cube and a pyramid. So to find the area of the cube, 6 times 6 times 6 equals 216 plus 1/3. This is a square base, so 6 times 6 is 36. Times 6 is going to be 216 again, but in this case it's going to be divided by 3. So 216 plus 72 is going to equal 288. Okay? And these problems are not any different than what I just did last week, actually, with my pre-algebra 8th grade students. So if you are having a hard time, you can go on YouTube, or if you're on YouTube if you're watching this video, and look at my pre-algebra review videos. Now we have a multi-step problem. You are using the funnel shown to measure the coarseness of a particular type of sand. It takes 2.8 seconds for the sand to empty out of the funnel. Find the flow rate of the sand in milliliters per second. So basically what we're saying is we're going to have to figure out how many centimeters of sand are in this, and then figure out if it takes 2.8 seconds for it to empty, how long that takes. And 1 milliliter is equal to 1 cubic centimeter. So to find the volume here, 4 squared is 16 times 3.14. That is the area of the circle. The height of this is 6. But it's a cone, so divided by 3 is 100.48 milliliters per 2.8 seconds. So milliliters per second, 100.248 divided by 2.8 is, it's falling at 35.88 is the flow. And obviously our numbers here are a little bit different once again because of rounding of this pi button. So they came up with 101, and then 101 divided by 2.8 is 36.07. We came up with 100.48 divided by 2.8 is 35.88. So now we're going to get into some guided practice examples for 3, 4, and 5. Examples 3 was simpler problems, 4 was using trigonometry, and 5 was multi-step. So find the volume of the cone, round your answer to 2 decimal spaces. We might be off slightly. And I thought problem 4 involved trigonometry, example 4, so this would be more of an example 4 type problem. So I want to find the length of this radius. So I'm dealing with the side opposite the 40-degree angle and adjacent. So opposite is my unknown, adjacent is 5.8, opposite and adjacent is tangent. Okay, so in my scientific calculator that you can't see, the tangent of 40 is 0.839099, etc. I'm going to multiply that by 5.8, and I'm going to get that this side length is 4.86, so roughly 4.9 inches long. Now to do the volume. 4.9 times 4.9 is 24.01 times 3.14 equals 75.39 times 5.8 is 437.27, etc. Divided by 3 is basically 145.76. And once again, rounding because of the pi button. So for problem number 5, a right cylinder with a radius of 3 centimeters and height of 10 centimeters has a right cone on top with the same base and height. Find the volume of the solid. So I'm going to draw a little picture there to help me. I have a right cylinder. So that's back to what we were doing yesterday with a radius of 3 and a height of 10. And has a right cone on top with the same base and the same height. So let's first do the cylinder. The area of the base, I'm going to put that over here because we're going to need that. 3 squared is 9 times 3.14 is going to be 28.26 times 10. So this volume is 282.6. The one on the top is going to have the same numbers, but at the end, because it's a cone, you're going to divide by 3 for 94.2. So 94.2 plus 282.6 is going to equal 376.8, which obviously we're getting further apart because of rounding. Double check. What if in example 5, suppose a different type of sand is used and it takes 3.2 seconds, find its flow rate. Well, if you remember, you can go back and look. We had a volume of 100.48. Because of pi, they said the volume was 101. So I'm going to do 101 divided by 3.2, and this has a flow rate of about 31.56 milliliters per second. And now it's time for the daily homework quiz. Find the volume of the solid. This is a square base, has an area of 36, times a height of 8 is 288, divided by 3 is 96. Find the volume of the solid. 12 squared is 144 for the radius, times 3.14 times 24, that number divided by 3. 3,617.28 is what we get. A slight difference because of rounding of the pi. For problem number 3, find the volume of the cube after the cone is removed. So we need to find the volume of the cube, the volume of the cone, and subtract the two. So the cube is 6.8 times 6.8 times 6.8. And it's 314.432. Obviously, we're going to have some rounding issues here. The diameter of this cone is 6.8. We want the radius, which is 3.4. 3.4 times 3.4 is 11.56 times pi equals that number times the height of 6.8 divided by 3 is 82.28. I'm going to round that too. So we're going to subtract the volume of the cone from the volume of the cube. And that's going to equal about 232.152. This one, our answer is fairly close. Still rounding, difference between using pi and 3.14. For the next question here, the volume of a right cone with height of 32 inches and radius r is 2,144.66. Find r equals 1/3 pi r squared h. And the radius we're supposed to find, and the height is 32. So I'm going to clear what I can on this side. I'm going to do 3.14 times 32 is 100.48. Wow, I feel like I've seen that before. Divided by 3 equals 33.493, etc. And that's radius squared. So I'm going to take this 2,144.66 and I'm going to divide it by 33.493. And I'm going to get, so I can see right away 64.03. That's going to be really close to 64. That's r squared. So r is going to be really close to 8. And I'm going to assume in this case that they want whole number, which they do, because when we had a question like this in the lesson, they wanted the dimension to the nearest whole number. They don't tell us this. And there you go, there's your homework. These first few problems deal with the lesson on density. And then here are the problems from lesson 11.7 on volume of cones and pyramids. I hope this has been thrilling for you, as it has been thrilling for me to make on Sunday evening of spring break.